female reproductive system consists of a pair of ovaries, a pair of oviducts, fallopian tubes, uterus, vagina, external genitalia, and a pair of mammary glands. Ovaries are the primary sex organs of a female. They are solid structures located in the lower part of the abdomen. It is connected by ligaments to the uterus and lateral pelvic wall. Each ovary is 2 to 4 centimeters long and 2 centimeters wide. It is composed of connective tissue called stroma, covered by a layer of germinal epithelium. Stroma has an outer cortex and an inner medulla. The ovarian cortex contains some rounded bodies, named follicles at various stages of development. Each follicle contains an ovum. Fallopian tubes or oviducts are narrow tubes, about 10 to 12 centimeters long, connecting the ovary to the uterus. Each oviduct is differentiated into 3 parts: infundibulum, ampulla, and isthmus. Infundibulum is the funnel-shaped proximal part, and has finger-like projections called fimbriae at its margin. Fimbriae are very close to the ovaries and receive the egg released from the ovaries. After release, the egg enters the fallopian tube. Tiny hairs in the tube's lining help push it down a narrow passageway, towards the uterus. Ampulla is the wider part of the oviduct next to infundibulum. It is lined by ciliated epithelium. Isthmus is the short, narrow, and straight part that follows the ampulla and connects with the uterus. The uterus is a hollow, muscular, and inverted pear-shaped structure. It is also known as the womb. It is located in the pelvic cavity between the urinary bladder and the rectum. The uterus is attached to the body wall by a double fold of peritoneum called myometrium. It has an upper dome-shaped part, fundus, middle large part corpus, and a lower narrow cervix that projects into the vagina. Implantation of embryo occurs in the uterine fundus. It is the site of fetal growth during pregnancy. The cervix is composed of powerful sphincter muscles. It is strong enough to hold the weight of the fetus and amniotic fluid against the pull of gravity during pregnancy. The cavity of the cervix is called the cervical canal. The uterus has a thick wall made of 3 tissues, an outer peritoneal covering called perimetrium, a middle layer of smooth muscles myometrium, and an inner glandular layer endometrium. The myometrium is involved in uterine contractions. The endometrium undergoes cyclic changes during the menstrual cycle. Vagina is an elastic muscular tube, about 7.5 centimeters long, that connects the cervix of the uterus to the exterior of the body by the vaginal opening. The cervical canal along with vagina forms the birth canal. During menstruation, the menstrual flow exits the body via the vagina. Menstruation is a woman's monthly normal vaginal bleeding, often called the period. When a baby girl is born, her ovaries contain hundreds of thousands of follicles, which stay inactive until puberty begins. There isn't one right age for a girl to get her period. But most girls get their first period about 2 years after their breasts start to develop, when they're between age 10 and 15. But it's different in each and every person's. Every girl's body has its own schedule. 2 structures in the brain, the pituitary gland and the hypothalamus, produce complex hormones that stimulate the ovaries to make female sex hormones that start and control the menstrual cycle. And it will continue till about age 51, usually lasting from 3 to 8 days. The menstrual cycle includes several phases. The first phase of the menstrual cycle begins on the first day of bleeding and lasts for about 14 days. In a normal menstrual cycle, the brain makes the hormone GnRH, which travels in the blood to the pituitary gland. The pituitary gland then releases two hormones, follicle-stimulating hormone, FSH, and luteinizing hormone, LH, which travel in the bloodstream to the ovary. These hormones cause about 6 to 12 follicles to be awake and start to mature. As they are going to mature, they release the hormone estrogen, which increases over and peaks in about day 12, and cause the lining of the uterus, endometrium, to begin to build up. It will become more thicker, and enriched with more blood vessels. Then one of those 6 to 12 follicles tends to grow a little faster, and becomes dominant. Then this dominant follicle moves to the edge of the ovary, to produce an egg. In fact, the woman's body prepares to get pregnant. On about day 14, the high amount of LH and FSH cause the egg to be released from the follicle. The high level of LH also causes a brief surge in testosterone, which increases sex drive, right at the most fertile time of the cycle. Once the egg is released, the follicle seals over and is called the corpus luteum. The corpus luteum starts producing progesterone. This progesterone has a negative feedback effect on the GnRH to reduce it and keep its frequency in a normal range. It causes and decrease the levels of FSH and LH. Other follicles disintegrate in the next few days. After release, the egg enters the fallopian tube. Tiny hairs in the tube's lining help push it down a narrow passageway towards the uterus. If the sperm cell can successfully meet an egg cell in the fallopian tube, the fertilization will take place in fallopian tube. If fertilization has occurred, the corpus luteum continues to produce progesterone, which prevents the endometrial lining from being shed. If the egg is not fertilized, it disintegrates after about 24 hours. Then the corpus luteum also disintegrates, which causes progesterone levels to drop and signals the endometrial lining to begin shedding after about 14 days. The menstrual blood is partly blood and partly tissue from inside the uterus. It passes out of the body through the vagina. The period comes again every 24 to 38 days, from the first day of one period to the first day of the next. Besides bleeding from the vagina, you may have abdominal or pelvic cramping pain, lower back pain, headache, fatigue, mood swings and irritability, food cravings, bloating and sore breasts. Milk is the essential food for a newborn baby. It provides all the nutrients necessary for healthy growth and development for the baby. Breast or mammary gland produces the milk in mother's body. Breastfeeding will foster a strong bond between mother and child. In this video, we'll explore the anatomy of mammary gland. How the mammary gland produce the nourishing milk that mother provides to their children. Benefits of breast milk and breastfeeding, for both the child and the mother. Changes occurred in mother's body, related to breastfeeding. Join us as we uncover the incredible process behind milk production and its vital role in early life. Mammary glands are a pair of external organs of the female. They are commonly called as breasts. Their main function is secretion of milk to nurture the baby. These are modified sweat glands and remain undeveloped till puberty. At puberty, they start developing under the influence of estrogen and progesterone hormones. The external surface of each breast has a projection called the nipple. Each nipple is surrounded by a circular pigmented area, called the areola. Internally, the breast consists of the glandular tissue, forming mammary glands, the fibrous tissue and the fatty or adipose tissue. In each breast the mammary glands are divided into about 15 to 20 compartments, called mammary lobes. Each lobe is made up of a number of lobules. Each lobule is composed of grape-like clusters of milk-secreting glands termed alveoli. These alveoli are responsible for producing milk. Mammary tubules connect alveoli with mammary duct. Several mammary ducts join to form a wider part, the mammary ampulla. It is also called lactiferous sinuses. There is an extension of mammary ampulla that carries milk to nipple is called lactiferous ducts. There are several lactiferous ducts, meets in each nipples. When a woman becomes pregnant, her body undergoes hormonal changes, primarily influenced by two hormones, estrogen and progesterone. These hormonal shifts prepare the breasts for milk production. Shortly before childbirth, another hormone called prolactin, which is responsible for milk production, increases in the woman's body. During pregnancy, under the influence of hormonal changes, alveoli begin to multiply and enlarge. By the time the baby is born, the mother's breasts have around 1,50,000 of alveoli in each breast. This is many times more than the number of alveoli that a non-pregnant woman has. Inside each alveolus, there are specialized cells called secretory cells, or alveolar cells. These cells are the key players in milk production. After delivery, when the baby begins to suckle's nipple, it stimulates the nerves in the nipple and areola, sending signals to the brain. Brain receives these signals and send instructions to the breast to produce milk. Then alveolar cells produce and secrete milk components such as proteins, fats, lactose, and immune factors. The hormone oxytocin is released from the pituitary gland in the brain in response to baby's suckle. Triggers the letdown reflex, also known as the milk ejection reflex. This reflex causes the muscles around the alveoli to contract and pushing the milk out from alveoli into the mammary tubules. Through mammary tubules, milk will reach into mammary duct. Through mammary duct, milk flows to mammary ampulla, where the milk may be stored before going to lactiferous ducts. Each lactiferous duct carries milk to the nipple. A nursing woman secretes 1 to 2 liters of milk per day. Breast milk production operates on a supply and demand basis. The more frequently and effectively the baby nurses, the more milk is produced. When the baby empties the breast during feeding, it signals to the body to produce more milk to meet the baby's needs. In the initial days after childbirth, the breast produces a thick yellowish fluid called colostrum. Colostrum is highly concentrated and contains antibodies and other immune factors to provide the baby with essential protection. After a few days, colostrum transitions into mature milk, which is thinner and lighter in color, but contains a perfect balance of nutrients, including proteins, fats, carbohydrates, vitamins and minerals, specifically tailored to meet the nutritional needs of a growing baby. It also contains antibodies and other immune factors that help to protect the baby from infections and diseases. Breastfeeding has many advantages for the baby's health and development. It helps strengthen the baby's immune system, reducing the risk of respiratory infections, ear infections, allergies, and other illnesses. Breast milk is easily digested, leading to less constipation and diarrhea. It is also associated with a reduced risk of obesity, diabetes, and certain childhood cancers. Breastfeeding provides several benefits for the mother as well. It helps the uterus contract and return to its pre-pregnancy size faster. Breastfeeding can also aid in postpartum weight loss as it burns extra calories. Additionally, breastfeeding has been linked to a lower risk of breast and ovarian cancer. The composition of breast milk can vary from woman to woman and can change throughout the course of breastfeeding. The levels of various components can be influenced by factors such as the mother's diet, health, and environmental factors. Breastfeeding promotes bonding between the mother and the baby. Physical skin-to-skin and eye contact during breastfeeding help strengthen the emotional connection between the two. For the first 6 months of life, the World Health Organization, WHO, recommends exclusive breastfeeding, meaning the baby receives only breast milk and no other foods or liquids, including water. At around 6 months of age, infants begin to eat solid foods, in addition to breast milk. Breastfeeding continues alongside the introduction of solids, gradually decreasing in frequency as the baby eats more solid foods. Stopping milk production, or breast weaning, is highly individual and there is no fixed age at which breastfeeding must end. This can happen gradually and naturally when a mother and baby are ready to stop breastfeeding. The key driver for milk production is demand. When a baby breastfeeds less frequently, the breast receives fewer signals to produce milk, leading to a gradual decrease in milk supply. Mother's body reabsorbs the milk that is already present in the mammary glands. The breast tissue gradually shrinks. This can result in a reduction in breast size over time. Some women may experience a smooth transition with minimal discomfort, while others may have more noticeable changes in breast size or experience mild discomfort as their bodies adapt. Wearing a supportive bra and cold compresses can help alleviate discomfort during the weaning process. During sexual intercourse, sperm enters the vagina and begin their journey. Sperm swim at a rate of about 1 to 4 millimeters per minute. During ovulation, cervical mucus changes, facilitating sperm passage through the cervix and into the uterus. The female immune system may recognize sperm as foreign and attack them. Some of the sperms will be destroyed in this attack. A pumping motion within the uterus helps propel sperm towards the egg. Cilia create a sweeping motion to help sperm to move inside the uterus, towards the egg. The egg releases an enzyme called chemoattractants that attract sperm towards unfertilized eggs. These enzyme, chemoattractants, attracts and directs the sperm towards the egg. Fusion of sperm and ovum is called fertilization. Fertilization is possible only during the first 24 hours after ovulation. Egg is surrounded by many sperms, but only one sperm can succeed in fertilizing the egg. Others will be degenerated. Sperm passes through the egg membrane, corona radiata, and reaches the zona pellucida. Acrosome, or the head of the sperm, releases an enzyme called hyaluronidase which facilitates the entry of the sperm into the egg. These enzymes dissolves the egg membrane and create an entrance for sperm. Soon after the entry of the first sperm, eggs secrete an enzyme which thickens zona pellucida. This prevents further entry of other sperms into the egg. Plasma membrane of the sperm will fuses with plasma membrane of the ovum. Sperm nucleus moves towards egg's nucleus and fuses with it. It is called karyogamy. This process leads to the mixing of genetical information of both parents. Female contains only X chromosomes. Male contains X and Y chromosomes. If X chromosome of male fuses with X chromosome of egg, baby girl will born. If Y chromosome of male fuses with X chromosome of egg, baby boy will born. This is how fertilization process occurs. Fertilized egg is called zygote. Following fertilization, zygote undergoes repeated mitotic division called cleavage. This occurs while zygote moves in the fallopian tube towards uterus. First cleavage is completed after 30 hours of fertilization. Zygote is divided completely into two. The daughter cells formed during cleavage are called blastomeres. Second cleavage is completed after 60 hours of fertilization. On the third day of fertilization, embryo reaches the count of 16 cells. The structure looks like a mulberry and is called morula. It is still surrounded by zona pellucida and reaches the uterus about 4 to 6 days after fertilization. As the morula enters uterus, it gets a rich supply of nutrients. Outer peripheral cells enlarge and flatten further. They form trophoblast or trophoectoderm. Trophoblast cells secrete a fluid into the interior, creating a cavity called blastocele. With the formation of blastocele, morula is converted into blastula. This is called blastocyst because of the peculiar cyst-like arrangement of blastomeres. Blastocyst has a single layered wall, the trophoblast, and a group of cells attached inner to it called inner cell mass. The zona pellucida disintegrates, facilitating the rapid growth of the embryo. Trophoblast then gets attached to the endometrium, and the inner cell mass is differentiated into an embryo. After attachment, the uterine cell divides rapidly and covers the blastocyst. The blastocyst becomes embedded in the endometrium of the uterus. This is called implantation, which leads to pregnancy. Normally, implantation takes place in about 10 days after fertilization. This multinucleate cytoplasmic mass aggressively burrows and digs its way into the endometrium and invades the uterine wall. It also starts to secrete a hormone called HCG. HCG is a pregnancy hormone that is crucial in maintaining the corpus luteum. The corpus luteum produces progesterone and stops the menstrual cycle. HCG helps sustain the corpus luteum until the placenta takes over hormone production. HCG is often used as a marker for pregnancy detection. Pregnancy tests detect the presence of HCG in urine or blood to confirm pregnancy. Elevated levels of HCG during early pregnancy are associated with morning sickness, which includes symptoms such as nausea and vomiting. HCG also helps establish immune tolerance in the mother's body and modulates the immune response to protect the fetus from being recognized as foreign tissue. Here, it begins to receive nourishment from the mother's body and continues to grow and develop. Over the next few weeks, the embryo undergoes rapid development, transforming from a cluster of cells into a recognizable human form. This is called embryonic stage. During the embryonic stage, which spans from week 3 to week 8, the blastocyst transforms into a complex structure with 3 primary layers, the ectoderm, mesoderm, and endoderm, which give rise to all the organs and tissues of the developing baby. Over the subsequent weeks, these layers give rise to the foundation of the baby's body. Neural tube begins to form in this embryonic stage, eventually brain and spinal cord, nervous system, and cardiovascular system will also begin to develop in this stage. HCG plays a role in the development of fetal organs and tissues, particularly during the first trimester. Toward the mid of the second week of development, some spaces called lacunae begin to form in the syncytiotrophoblast. These spaces fuse together to form a network filled with maternal blood of the damaged endometrium. Finger-like projections called chorionic villi begin to extend like the root of the plant and are surrounded by a pool of maternal blood. Here is where the exchange is happening. Maternal blood rich in oxygen and nutrients flows into the intervillous space and diffuses across the placental membranes into the fetal blood. At the same time, waste products and carbon dioxide move from the fetal blood into the maternal blood for elimination, while the blood will never mix. Also, this process anchors the placenta to the uterine wall, ensuring a stable connection. The umbilical cord, which attaches to the fetus, transports nutrients and oxygen to the fetus and removes waste product. The umbilical cord is rich in stem cells that have the ability to differentiate into various types of cells, such as bone cells, fat cells, and are responsible for generating the different types of blood cells. The length of the umbilical cord can vary among individuals, averaging around 55 to 60 centimeters. The placenta is fully formed and functional by the end of the first trimester, around 12 weeks of pregnancy. It acts as a bridge between the mother and the developing fetus, facilitating the exchange of essential substances, waste elimination, hormone production, and immune protection. The placenta also acts as a selective barrier to filter out toxins, pathogens, and drugs that could harm the fetus. Also, the placenta assists in regulating the fetus's temperature, ensuring a stable and optimal environment for development. Limbs are also started to form in this stage. By the end of the embryonic stage, around 8th week, the embryo officially transitions into the fetal stage, which spans from week 8 to week 13. From this point onward, the focus shifts to growth and refinement of existing structures as the fetus continues to develop recognizable facial features, fingers, toes, and a rapidly expanding brain. The fetal skeleton continues to develop, with bones becoming more defined as cartilage transforms into bone tissue, providing support and structure. The fetus's senses continue to develop, with the ability to sense light filtering through the womb. Facial expressions may also begin to emerge. During the second trimester, from week 14 to week 27, the fetus experiences a period of rapid growth and maturation. Organs mature, muscles strengthen, and the fetus becomes more mobile, responding to touch, sound, and light. The fetus may be able to hear sounds from the outside world, such as the mother's heartbeat or voice. A protective substance called vernix begins to form on the fetus's skin. Vernix helps to protect the fetus's delicate skin from the amniotic fluid and prepares it for life outside the womb. The fetus's lungs continue to mature, with increasing production of surfactant to support breathing after birth. The respiratory system is preparing for the transition from receiving oxygen through the umbilical cord to breathing air independently. In the third trimester, from week 28 until birth, the fetus undergoes final preparations for life outside the womb. The baby settles into position for birth, and the mother may experience Braxton Hicks contractions as her body prepares for labor. As the third trimester begins, the fetus experiences a period of continued rapid growth and development. Organs mature further, muscles strengthen, and the fetus begins to settle into position for birth. By this stage, most of the fetuses will settle into a head-down position in preparation for birth. This positioning helps to facilitate a smoother delivery process. The fetus's lungs are nearly fully developed, with surfactant production reaching optimal levels to support breathing. The fetus practices breathing movements, inhaling and exhaling amniotic fluid to help strengthen the respiratory muscles. Towards the end of pregnancy, the blood vessels within the placenta become more organized and developed and adequately supports the fetus until delivery. As the delivery approaches, the placenta produces higher levels of hormones, including prostaglandins. Prostaglandins play a role in cervical ripening, which will help in softening and thinning of the cervix in preparation for labor. They help prepare the cervix for dilation and facilitate the onset of contractions. During labor, the placenta reserves oxygen and nutrient to ensure that the baby receives sufficient oxygen and nutrients even during the temporary reduction in blood flow caused by uterine contractions. And finally, the moment arrives, the miracle of childbirth. Childbirth typically begins with the onset of early labor, which can last for several hours or even days. During this stage, the cervix begins to dilate and efface in preparation for the baby's descent through the birth canal. With each contraction, the mother brings her baby one step closer to meeting the world. As the uterus contracts during labor, the placenta begins to detach from the uterine wall. This detachment is a natural process that allows for separating the placenta from the uterus tissues after the baby is born. The transition phase marks the final stretch of labor, where the cervix fully dilates to 10 centimeters. With one final push, the baby emerges into the world, greeted by the loving arms of the mother and the cheers of the medical team. Once your baby is born and the cord stops pulsating, it's time for the cord to be cut. Doctor will gently clamp the cord in two places, usually about 4 to 6 inches away from your baby's belly. Then cut the cord between the two clamps, creating a clean and safe separation. In the immediate postpartum period, the medical team attends and assists with the delivery of placenta. After the baby is delivered, the uterus continues to contract to expel the placenta. These contractions, often called after-birth contractions, help detach the placenta entirely from the uterine wall and push it out through the birth canal. The doctor may gently assist in the delivery of the placenta by applying controlled traction on the umbilical cord or by applying pressure on the mother's abdomen. The process of placental delivery may take a few minutes to up to an hour. The doctor monitors this process to ensure that the placenta is delivered entirely and that there is no risk of retained placental tissue, which can cause complications if left behind. The doctor also examines the placenta maternal side for abnormalities. On average, a placenta typically weighs between 500 to 600 grams. Some people are advocates of eating the placenta, also known as placentophagy. They claim potential benefits due to the presence of various nutrients and hormones in the placenta, such as increased mode, increased energy levels, enhanced milk production, and hormone regulation. Yet there is no scientific evidence regarding the benefits or risks of consuming the placenta. But it's important to note that there are potential risks associated with consuming the placenta. The placenta may contain bacteria, viruses, or toxins, and improper handling or preparation could increase the risk of contamination and infection. Cooking or processing methods, such as steaming or encapsulation, may not effectively eliminate these risks. Some countries or regions have specific guidelines or restrictions in handling placenta. Therefore, it is essential to be aware of local regulations and guidelines related to placentophagy. And so, from the moment of fertilization to the miracle of childbirth, the journey of human reproduction is a testament to the wonder of life itself.